SQLite is a C language library that implements a small, fast, self-contained, high-reliability, full-featured SQL database engine. It is the most used database engine in the world. SQLite is built into all mobile phones and most computers, and comes bundled inside countless other applications that people use every day. The code for SQLite is in the public domain and is thus free for use for any purpose, commercial or private. SQLite is an embedded SQL database engine. Unlike most other SQL databases, SQLite does not have a separate server process. SQLite reads and writes directly to ordinary disk files. A complete SQL database with multiple tables, indices, triggers, and views is contained in a single disk file. The database file format is cross-platform. You can freely copy a database between 32-bit and 64-bit systems, or between big endian or little endian architectures. In this video, you will learn how to install SQLite and use its command line tools. You will also learn how to work with SQLiteStudio GUI tool for managing SQLite databases. Let's take a look at SQLite data types and their concepts. Most SQL database engines use static or rigid data types. SQLite uses a more general dynamic data type system, meaning a value stored in a column determines its data type, not the column's data type. The dynamic type system of SQLite is backwards compatible with the more common static type systems of other database engines, so statements that work on statically typed databases work the same way in SQLite. Now let's take a look at some of the SQLite storage classes. Null is a null value. Integer is a signed integer stored as 0, 1, 2, 3, 4, 6, or 8 bytes, depending on the magnitude of the value. Real is a floating point value stored as an 8-byte IEEE floating point number. Text is a text string stored using the database encoding of UTF-8, UTF-16BE, or UTF-16LE. Blob is a blob or binary long object of data stored exactly as it was input. SQLite does not have a separate Boolean storage class. Here, Boolean values are stored as integers, 0 for false and 1 for true. Let's take a look at SQLite date-time data types. SQLite does not have a storage class for storing dates or times. Instead, the built-in date and time functions of SQLite are capable of storing dates and times as text, real, or integer values. Text is stored as ISO 8601 string. Real is stored as Julian day numbers, and integer is stored as Unix time. Applications can choose to store dates and times in any of these formats and freely convert between formats using the built-in date and time functions. Here are some of the date and time functions. Date as text in this format, time as text in this format, date and time as text in this format. Julian day are fractional number of days since noon in Greenwich on November 24th, 4714 BC. Unix epoch is a Unix timestamp of the number of seconds since 1970-0101 UTC. strf time is the date formatted according to the format string of the first argument. Time diff is the amount of time that must be added to B in order to reach time A. Let's take a look at the steps for installing SQLite. First, we will go to SQLite.org. Then click on the download button. Since we will be installing SQLite for Windows, we will select under precompiled binaries for Windows the zip file that contains a bundle of command line tools. Here we can see the downloaded zip file. Next, we'll create an SQLite folder and move the downloaded zip file to the folder we just created. Now we will extract the contents of the zip file into the SQLite folder. 3 files were extracted: SQLDiff.exe, SQLite3.exe, and SQLite3_analyzer.exe. Here are some descriptions of the SQLite command line tools. SQLite3 is a simple command line program that allows the user to manually enter and execute SQL statements against an SQLite database. SQLDiff is a command line utility program that displays content differences between SQLite databases. SQLite3 Analyzer is a command line utility program that measures and displays how much and how efficiently space is used by individual tables and indexes with an SQLite database file. Let's take a look at some examples using the SQLite3.exe command line tool. First, we will create a database named mycompany.db. If mycompany.db did exist, then this command would open it. Alternatively, at the SQLite prompt, you could use the .open command to do the same thing. Entering .help gives a listing of available commands. Next, we will create a table named employee. Then create a column named ID of type integer as a primary key, and a column named employee number of type integer, a column named first name of type text, a column named last name of type text, and a column named hire date of type text. Next, we will create a table named salary. Then create a column named ID of type integer as a primary key, and the column named employee ID of type integer, a column named salary of type real, and a column named date of salary of type text, followed by referencing the ID column of the employee table. The .tables command shows the tables that are contained in the mycompany database. Next, we will insert 2 rows into the employee table, then list the rows in the employee table. Now we will insert 2 rows into the salary table, then list the rows in the salary table. Here we can see mycompany.db has been created in the SQLite folder. For this example of using SQLDiff, we will use 2 identical databases, carparts1.db and carparts2.db, that contain 2 tables, customer and parts order, with pre-populated data in each table. The --help switch shows a list of available options that can be used with SQLDiff. Using SQLDiff on both of the databases, we can see there was no difference found, since they are identical. Now let's open carparts2.db and add 2 rows to the customer table. Then run SQLDiff again. Here the output displays the commands that are necessary to transform carparts1.db to carparts2.db. Reversing the databases shows what is necessary to transform carparts2.db to carparts1.db. Next, we'll look at an example using the command line switch -- schema that shows only column name and table differences in the schema, not the table content. First, we'll open carparts2.db, then add a column called total quantity of type real to the customer table. Using the command line switch -- schema, the output displays the commands that are necessary to transform carparts1.db to carparts2.db. Reversing the databases shows what is necessary to transform carparts2.db to carparts1.db. In this case, it shows that the customer table will need to be deleted and recreated using the given schema. The SQLite3 analyzer.exe binary is a command line utility program that measures and displays how much and how efficiently space is used by individual tables and indexes with an SQLite database file. Example usage looks like the following. The output is a human-readable ASCII text report that provides information on the space utilization of the database file. The report is intended to be self-explanatory though there is some additional explanation of the various parameters reported toward the end of the report. The output is also valid SQL. Most of the report text is contained within a header comment with various SQL statements that create and initialize a database at the end of the report. The constructed database contains the raw data from which the report was extracted. The original report can be read into an instance of the command line shell, and then the raw data can be queried to dig deeper into the space utilization of a particular database file. Let's take a look at an example using SQLite3 Analyzer on the carparts2.db database. The output provides a report detailing size and storage efficiency information for the database and its tables and indexes. Information is provided for each table, followed by definitions of each item. The end of the report contains various SQL statements that create and initialize a database. The constructed database contains the raw data from which the report was extracted. Hence, the original report can be read into an instance using the command line shell, and then the raw data can be queried to dig deeper into the space utilization of a particular database file. The SQLite3 command line shell works well. However, sometimes you might want to work with SQLite databases by using an intuitive GUI tool. SQLiteStudio tool is a free GUI tool for managing SQLite databases. It is free, portable, intuitive, and cross-platform. SQLiteStudio also provides important features such as importing and exporting data in various formats including CSV, XML, and JSON. In this next video, you will learn how to install SQLiteStudio and explore some of its uses. Let's take a look at the steps for installing SQLiteStudio. First, we'll go to the SQLiteStudio website and click on the download button. Then open up the download folder and run the installation that was just downloaded. Click on the next button and select I accept the agreement. Then click on the next button and accept the defaults. Select Launch SQLiteStudio Now and click Finish. Let's take a look at an example of creating a database and two tables using SQLiteStudio. First, we'll create a database and we'll name it carparts3.db. Next, we'll connect to the database and we'll create a table and we'll call the table Customer. Now we'll create a column called ID of type integer, assign it as a primary key, and set it as auto increment. Next, we will create a customer number column of type integer, and we'll create another column called first name of type text, and a last name column of type text, an address column of type text, a city column of type text, a state column of type text, postal code column of type text, and a country column also of type text. Then we'll commit this table to the database. Next, we'll create a second table, and we'll call it Parts Order. Now we'll create a column called ID of type integer, assign it as a primary key, and set it as auto increment. Next, we'll create a customer ID column of type integer, assign it as a foreign key, and have it reference the ID column of the customer table. Then we'll create an order date column of type text, and create a ship date column of type text, a quantity column of type integer, an item number column of type integer, an item name column of type text, and a cost column of type real. Now we will commit this table to the database. In the left-hand pane, we can see the two tables that were created, along with their columns. Let's take a look at an example of how to enter data into the customer table using SQLiteStudio. First, we'll click on the Data tab, then click on the Insert Row button. Next, we'll enter data for customer number, first name, last name, address, city, state, postal code, and country. Then we'll click on the Commit button to add this data to the customer table. Here we can see that an ID of 1 was added automatically since we had defined this column as auto increment. An alternate way of entering data can be done by importing data using a CSV file. For this example, we created a CSV file as shown here. Since the last row entered in the customer table contains a 1 for the ID column, we have started ID with a value of 2. This is necessary since the ID column has been defined as a primary key where no duplicates are allowed. Now we will click on the Import Data to Table button and select the customer table. Then click Next. Select CSV as the data source type. Select the CSV file to import, and select comma as the column separator, then Finish. Here we can see the data that was just imported. Here we will take a look at how to apply data encryption using SQL Cipher to an SQLite database. SQL Cipher is a security extension to the SQLite database platform that facilitates the creation of encrypted databases. SQL Cipher is an open source library that provides transparent, secure 256-bit AES encryption of SQLite database files. All data in the main database file is encrypted. The encryption algorithm is 256-bit AES in CBC mode. Let's create an encrypted database with a password. For database type, we'll select SQL Cipher. Then we'll create a database named mysecuredata.db. Next, we'll add a password, which can be a maximum of 16 characters. Then click on OK. Then connect to the database. In order for the password to be applied, you'll need to create something in the database. So we will create a table that has an ID column of type integer, that is a primary key and has auto increment set. Now we will remove the database from SQLiteStudio and then add it back. Here we will enter an incorrect password and see an error message is generated. Entering the correct password opens the database successfully. I hope you found Introduction to SQLite helpful. If you have, click on the like button. And to receive any updates to this channel, click on the subscribe button. Thank you so much for watching.